Here's what they do in the book. They're going to take and they're going to divide everything by this expression right here. Make sure I'm looking at it right. Yep. Let's just see how this works out, because honestly, I wouldn't have thought to do this. This is a really, I guess the thought is here that if I divide that out, there's a lot of, I don't understand how I don't understand how they came up with that, but this is what you do. So let's just kind of look and see, maybe we can figure out why they might have decided to do this as we work, okay? So let's see. Well, here's what I'm saying. They take each one of these terms, so on the top you've got sine x cosine y. They're dividing it by cosine x cosine y. And then they're taking the other term on the top, cosine x sine y, and they're dividing it by this cosine x cosine y, and that's that factor I circled on the bottom. That's just what they did to the numerator. I'm going to separate it with colors here. Green bar is now my fraction bar from up here, okay? I'll kind of color code here. Below it, here's what they did. They took that cosine x cosine y, and they divided it by cosine. They're dividing every single term by the same thing. That's a valid math strategy, isn't it? To divide everything by the same thing, and it would stay equal. Why they knew to do this, I have no clue.
Can you separate out the denominator then?
Oh, I'm not separating it out. I am just deciding that I'm going to divide each term by something. And it's not that I'm separating the denominator out. They just decided to divide each term by the same thing, and the thing they decided to divide by was this thing I circled in red. Okay. It's not like that they're separating it out, because I still, if you look, let me kind of do this in yellow so it won't mess up too much. There's still my whole top, right? And let me get like another light pale color. This right here is still my whole denominator right here, isn't it? All they've done is that thing I circled in red above, they divided each term by that. Again, how they knew to do that, I have no clue. Some of these get really hard. These would not be test problems, but they're good ones to push your thinking on anyway. So what's interesting to me is that this is the third year I've taught this and nobody's ever asked about this problem. So there's not a video on it because nobody ever asked about it. It makes me wonder if everybody just kind of wrote down junk and skipped it or something. I don't know. Either that or they were very intelligent. Which, you know, at this stage in the game, that would be a hard thing to think to do, wouldn't it? That's not something I would have thought to do. All right, so how is that going to simplify stuff? I have a feeling that what's going to happen now is that, yeah, a lot of stuff's going to cancel out. If you look, let's look at stuff that cancels out. Let me do my canceling out in kind of a purple color. This would cancel out. Over here, I have a cosine x that would cancel out, right? Over here, this whole thing is, all this whole thing cancels out and just becomes a 1, doesn't it? This term right here, because that's what I divided by. Something divided by itself is 1. And then over here, your sine y's would cancel out, wouldn't they? How they knew to do that, I don't know. I guess they were thinking, if I could just divide something out of if I could divide by something that would cancel a bunch of factors out, let's do that, and they figured that out. Thanks. So let me fix this. Let me fix this a little bit. So cosine x, cosine y. Okay, bless you. So did anything cancel out of that last fraction? Okay. So, okay, I see what's going to happen though. Let's see what cleans out here. On the top, don't I have here sine x cosine x, right? What is sine x cosine x? What is a sine over a cosine? It's a tangent. So instead of let me go ahead and, instead of rewriting this mess, that right there turns into a tangent x on the top. That first term turns into tangent x. Now, I'll try to just use some different colors. This right here, you got sine y over cosine y. What does that turn into? Tangent y. Okay. Now let me draw my green middle fraction bar. Here I have a 1, don't I? I mean, we already saw that everything divided out here, so that's a 1. And then over here I have Sine it, let me write what I have here because this is going to be the part. Sine x, sine y over cosine x, cosine y. What if I grouped those? Isn't this right here tangent x? So that's going to become a tangent x because sine over cosine is tangent. What's this going to become right here? What's sine over cosine? Sine y over cosine y. Tangent y. Oh, look, we have what they have now, don't we? I could have sat here for 2 hours and never thought to do this, okay? On the top, we have tangent x plus tangent y. Isn't that what they have on their right-hand side? Right? Okay, we're there. And then on the bottom, it's 1 minus oh, I miscopied the subtraction sign, didn't I? So let me go back. I miscopied it. Here it was, and then I just didn't, when I came down here, it should have been a minus here, so now I have 1 minus tangent x, tangent y. I wonder if, okay, the book shows it worked out this way. It shows that that's what they're doing. I wonder in this case if it might have been easier to start on the right and rewrite everything in terms of sine and cosine. I don't know whether that would have fallen out any better. I don't really see that it would because you would have had sine x over cosine x plus sine y over cosine y. It would have been a mess either way. Again, here's a strategy they used. I wouldn't have thought to do it, okay? I would not have thought to do that. This is one of those that if I hadn't had the answer key, I probably would have worked forever on it. Made tons more mistakes. Just even miscopying things from line to line can get you right, even if you kind of get on the right track. One thing I noticed about this one is I got a square root, and on the other side there's no square root. How do you get rid of a square root? Do you multiply by another kind of another square root thing? Like if I had square root of 3 and I wanted to get square root of 3, wouldn't I multiply by another square root of 3? Square root of 3 times square root of 3 would give me 3. So I kind of am thinking I need to multiply. I'm going to be taking this first part. And I'm going to multiply by something under a square root. And what is it going to be? Well, let's look at where they go with this. When I get done, I still have a 1 plus sine theta over there, don't I? Doesn't it look like what needs to happen? If you look at where we're going with this, if this is all of a sudden out of the radical and it stayed the same, it looks to me like what we need to multiply is 1 plus sine theta. And again, if I'm going to multiply something, I have to multiply by 1, right, to keep the fraction equal. Is that going to work? Anybody see where this is going yet? Okay, if you don't, let's work under the radical. What I have now on the top is I have 2 copies of the same thing. This is like saying square root of 3 on the top times square root of 3 would be 3. It's just square root of 1 plus sine theta and square root of 1 plus sine theta. Let me just do the top part, okay, and just follow that logic through. This is the same thing. Isn't it the same thing as saying that's 1 plus sine theta squared, right? Because there's 2 copies of them. And if I take the square root of something that I got 2 copies of, don't I just get the same thing back? You kind of see what we're doing on the top at least. Okay. I just needed 2 copies of the same thing to get it out of the radical. And that's what led me to know what to do here. Because look at the bottom. On the bottom what we have is 1 minus sine theta times 1 plus sine theta. That's a difference of 2 squares, isn't it? So that would be the difference of 2 squares. If you have something minus something and that same thing plus something, it's the first thing squared, so it's 1 squared, which is 1, minus the second thing squared. Wouldn't the second thing squared be 1 minus sine squared theta? Right? Do we have an identity for what 1 minus sine squared theta is? Sine squared theta plus cosine squared theta is 1, so what would it be? It'd be cosine squared theta. If you took sine squared theta plus cosine squared theta is 1, and you subtracted sine squared from each side, you'd get that 1 minus sine squared theta would be equal to cosine squared theta. But now this is still under the radical, isn't it? The top part was easy to get out from under the radical. Do you remember that when you're taking square roots of fractions, you can take the square root of the top and the square root of the bottom separately? That's an algebra thing. You know, square root of 4 over 9 would be the square root of 4 is 2 on top, and the square root of 9 is 3 on the bottom. This is getting back again to just something that we know from way a long time ago. So I still need the square root on the bottom. But what is the square root of cosine squared?
Cosine.
It's just cosine theta. Now, why do they have the funky, why do they have this on it? Is that we're at the answer already, aren't we? It's because when I came down here and I'm looking at this square root, let me try to write it a little cleaner. It's square root of cosine squared theta. Can I take the square root of a negative number and get a real number? No. So really, I should come in here and say, oh, my absolute value brackets need to back up even a step, because I've got to make sure that when I square root cosine theta, I'm only talking about the positive root, because I can't square root a negative number. So if I look here and I think about why is that there, it's because I can't square root a negative number, so I need to show it here. And I know that's really sloppy, but I'm hoping that at least you could follow it verbally, even though it kind of ended up pretty sloppy there. So that's actually 33, how we would get around it.